Hey guys, welcome back to Consistent Code. So today's problem of the day is the Smurfs. So you can read all of this problem statement, but I'm just gonna explain you this problem in a simplified manner. So basically what this problem says that you are given an input n, let's say n is 5, and let's consider the example test case only. You are given n as 5, and then you are having an array of characters which can consist of R, G, and D. So let's consider this character R, G, B, R, D. Alright, so you are given R, G, B, R, D. Now what you need to do, you are given two, uh, you can say statements. That first is you can convert R plus G into blue, or G plus blue into R, or you can consider the third one as R plus B equals to G. So basically you can convert X plus Y into Z, where X, Y, Z are different. Okay, and X, Y, and Z should belong to R, G, and B. That is, X, Y, and Z could either be R, G, or B, and if all of them are different, then this condition applies, that X plus Y is equals to Z, and you can consider all other cases also. So you can just check this out, right? And the second condition they have said is that if you want to convert this, suppose I want to convert this R and G, then I can convert this into B, but they have said they should be adjacent. Okay, so I can convert this one, but if I want to convert this R and this blue, then I cannot do this because they are not adjacent. But yes, once I have converted this R and G into B, then this becomes P, B, R, P. Then I can convert this one, and this will become B, then BR will be G, then B. Then I can convert these two because they are adjacent now. So this becomes RB, and this is further reduced to G. So finally we get only one remaining, or one element remaining. So this is what we need to output. For this the output has to be 1, right, as you can see. So I hope you understood the question now, that we just need to find the minimum number of elements remaining after we have performed these operations satisfying these two conditions, right? So now let's discuss how to approach this problem. Okay, so for that I want that you need to make few observations here. Let's consider the very first observation, that you can only merge X and Y to form Z if X and Y are different. Okay, what if you do not have any different color, right? So first is, if you have all the elements same, right? Suppose you are given an R, and so on, or maybe you are given blue, 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 or maybe green, green, green. So in all of these cases, your answer will be N, because you cannot make any operation because they are same and you need different colors, right? So for all these cases, whatever will be the size of array, this is size of the array, this becomes our answer, right? Now let's consider another observation which you should make here. The second is, let's say, even if you have R, and so on, you can have any number of R's, or you can even have blue or green, any number. I'm just saying that even if you have a lot of them and you have only one different color, okay, let's say we are having G, then this single G is capable to reduce complete this into only one. How? Let's see. If you can consider R and G, then this becomes R, then blue. Then this R and B can again be converted into R and G. this R and G can again be converted into R and B, and this R and B can be again converted into G. That is, you get in the end only one, right? So what is this observation which you can make, that if you are converting X and Y into Z, then this Z can always be again matched with Y and X, right? If you are using R, G and B to R plus G equals to B, then this blue can again be matched with G also and R also. So even if we have only one different character and all rest are same, the complete expression can be converted into one, right? So from this thing only, what can we deduce now? Let's see that. So what we can deduce, that let's consider something like, if you are now, let's consider some cases. Let's say you are given R. We have considered the case we are having only one color, so for that answer is N. Now let's consider cases when we have more than one color. Okay, so let's consider we have R, G and B. Let's say we are having this case. So in this case we can either convert it into B and B, or you can convert it into R and R, right? You can either match it from here or you can match it from this side, like this or maybe like this, right? So this is one thing. And now let's consider another case when we are having this was the case when we are having odd number of R's, odd number of G and odd number of B, right? Why am I saying that this is valid for all of them? Because you can just check for other cases also. You can just see R, G, B, R, G, B. This will be the case when it is even. Let's consider the even case also. So when R, G and B are even, now you can see this R and G can be converted into B. Then this B and R can be converted into G. Now this BG and GB can again be converted into R and R. So here also we are having two numbers remaining, and when it was odd number, then also we are having two elements remaining, right? And now you can just consider all other cases also. Even if you have R as 2, G as 2, B as 2, you will get 2 only in the end. Okay, you can just try and it's like hit and try. And now let's consider the other cases. Suppose we are having R as 2, blue as 2 and green as 1. Let's see this case, G. So in this case, first of all, what we can do, we need to make it minimum. So we can consider this one. So this will become R, R, B and R. Then this red and blue can again be converted into R, R, G. This can again be converted into R and B, and this can be converted into this G. Okay, so similarly you can just check for other cases also, like you can consider R as 2, B as 1 and G as 2. You will again get the last element as 1, or last remaining element will be only 1, and other you can check other cases also. So by this hit and try, you should be able to observe that if, because when we have checked for R equals to 1, B equals to 1, G equals to 1, and we have also checked for R equals to 2, B equals to 2 and G equals to 2. Now if you check for R equals to 3, B equals to 3, G equals to 3, you will get the same thing happening which happened for this case. And this is true for all odd numbers. Okay, all odd cases the same thing happens, which happens for r equals to 1, b equals to 1, c equals to 1, and this is the case for even. So either you can say if r is odd, b is odd, and g is odd, then in that case your answer is 2, and otherwise r is even and b is also even and g is also even, then also your answer is 2. Okay, and for all other cases you can see that suppose it was r r g g b, then in this case these all match up to in the end find make one pair, and this color will be either r or either g, and this can be matched with b to again form either you can say that is only one color. So in all other cases answer has got to be 1. So yeah, this was you can say not kind of intuitive. You need to just hit try and run the test cases, but this is the way you have to find out. This is kind of a puzzle. So now let's just code it out. Okay, so first of all let's say that r is 0, then g is 0, and d is also 0. Now let's calculate their frequencies. So we can just run a for loop and check if the AI is A, then we can say, sorry, not A, it's R. It's R plus plus. Otherwise, we can see if AI is, G, then we can increment the frequency of G. Otherwise, it has got to be blue only, so we will just increment the frequency of blue. Now, what was the first thing we checked? That if all the characters are same, that means either R will be equal to N, or green will be equals to the N, or maybe blue is N. In all of these cases our answer will be N. Okay, and in other cases if R is odd, so let's say if R is odd and blue is odd and green is also odd, let me put them in parentheses. So if R, red, green and blue are all odd, the answer is 2. And similarly, if let's take R mod 2 or R, let's use the bit only. If R and 1 is 0 and blue and 1, that is the last bit of blue, is a 0, and green and bitwise end of green is a 0, then in that case we are also returning a 2. And in all other cases we can simply return the answer as 1. Or maybe I think it would be better to not use these bitwise operators, because maybe some of the viewers may not be knowing about bitwise operators. So let's just do it using modulo 2. So if we can just consider if either green is even and blue is even, and green, blue and red mod 2 is also even, then we can return 2. And otherwise if we do not need an else statement here because we are already returning. So if green mod 2 is 1, that is if it is odd. If blue is odd and green, blue, and then red is an odd, we can return a 2. So now let's try compiling and running our code and see if this is working. So yeah, it's getting the correct output. So now let's try submitting the code. So we have solved this problem successfully, and I hope you liked the explanation. And if you did so, make sure to hit the like button and subscribe to the channel, and I will see you tomorrow with the next problem of the day.